Hello everyone and welcome to our very first full tutorial on how to use Kubernetes. So prefix for this video is this is just the beginner's course, like the very basics of Kubernetes and the sort of basic troubleshooting that you'd use. I do talk about some real world examples and how you could use Kubernetes and what you'd actually use certain services and resources and how to use them. So in the next sections and future videos, we are going to go into more depth into them and talk about them a little bit more. But this is just a 1 hour course or 1 hour or thereabout course to kind of let you guys into the beautiful world of Kubernetes and get you started with this. So I hope you guys enjoy it. If you do enjoy it, please make sure to leave a like and subscribe because these videos do take a long time for me to make, and I hope you guys enjoy it. So let's get started. Okay, so in this episode, we're going to look at how to install Minikube on your local terminal. So head over to Google, type in Minikube, and the first thing that should show up is this Minikube start. I'm going to click on it. You can choose your operating system, and by default it will select what you're on. I'm currently on Windows, but I'm using WSL, so I like to head over to Linux, and it gives you the few steps that you need to actually get started with your cluster on Minikube. We're going to copy over this command and head over to our terminal. It's going to take a minute to download because I'm also downloading some other things, I believe. Once that's downloaded, you just copy the other command that's below the curl, which just installs Minikube and removes removes the actual installer as well. So after this, you should have it, and you can type in Minikube start, and this should start up your cluster on your terminal, for example. You can do this on Mac OS, Windows, by default Linux, and all other systems. As you can see, I'm using the WSL Windows subsystem for Linux on Windows, and then it's actually working quite well. So we can actually, now we get access to all the commands. We can do get pl-a, get all the pods that are running. From the get-go, you've got a few things running the kube system that are necessary: etcd, core DNS, every sort of thing you'd expect from a default start of a Kubernetes cluster, and that's pretty much it. Over in the next lecture, we're going to start looking at actually how to create some namespaces, look at services, pods, and other things native to Kubernetes. So with Minikube, there's a few commands that you can actually use to manage your cluster locally. The kind of big ones is Minikube pause, which actually pauses Kubernetes without actually impacting any deployments that you may have running. So if we do Minikube pause, for example, we'll pause it for us, and then we can do Minikube status, and it will show you that the kubelet is stopped, API server is paused, everything else is configured, host is still running. That's the main thing that lets all the applications not be impacted. If you want to unpause it, you just type in Minikube unpause, and this would bring everything back up to life as you expect it, and you can see now everything's running. The host is running, kubelet, API server, and it's all good. Another thing, for example, if you're running low on memory, or you want to limit the memory of Minikube running on your computer if it's using too much, or if it's using too much RAM, for example, you can actually set this Minikube config set memory command and define how much memory you want it to use. This would limit it to 9 gigabytes. I'm currently fine with the amount of RAM it's using. We're quite a powerful machine. Minikube offers a lot of add-ons that you can Minikube add-ons list, and it'll actually show you everything that's available to add. So for example, if you want like your cluster to run Istio, which is a popular service mesh, and it's quite handy for microservices application to have running, you can do that. I think it has Grafana, maybe. Does it have Grafana? I can't see Grafana. I think it has Prometheus. No, it doesn't. I thought it maybe used to, but it doesn't. It definitely did have, it has Ingress DNS, Helm stuff, GCP, EFK, stuff that you want to usually try out, and you can install that by default, and it'll start running in its own namespace, and you have it up and running without actually having to do it yourself. It's a good way if you're just focusing on your application to get things running. But if you want to try and run these things yourself, it's worthwhile to either try installing them manually for a file, or try with a more advanced way to install it with Helm or Customize or something along those lines. But I think these are the kind of main sort of cluster management commands that you'd actually use while using Minikube. So in the next step, we're going to start looking at creating some pods as well. So in this section, we're going to start looking at pods and how we can actually start creating them. There's a few ways in how you can create pods. You can define a YAML file where you define all the metadata specs for your containers and what you want to run in them. Or if you just need a simple pod to be started up of Nginx, you can do it quite quickly with a command. So let's start off with the command way. So if we do kubectl run name of our pod Nginx and define the image Nginx, if I can type correctly, there we go. And that's how easily you can create a pod inside of Kubernetes. Now we can do kubectl get po, and we can see our Nginx has already started up and it's running. The other way, where if you want to define more, if you want to define the files and reuse them quite easily, we can create a YAML file. I'll show you the specification. If we do, then let's call it a simple pod just now, and we can just copy the sort of example that they give you on the Kubernetes documentation. So as you can see, we define the API version. It's always v1 at the moment. They haven't released the version 2 of the Kubernetes API. The kind of the resource that you're creating, in this case we're creating pod, and then metadata, where we can define the name of the pod. We don't want to use Nginx at the moment because Nginx 2, for example. And then inside, and we've got the specification where we've got our containers. We can do Nginx 2 as well. The image, we can just default it to the latest Nginx image, and the ports that the container are going to use. We can save this, and we can apply it quite simply, also using the kubectl command by doing apply -f, where we specify the file, and we do simple pod. And now we've got our Nginx pod, Nginx 2 pod being created, and we can run the same command, get po, and we can see our second pod has been created. Both are fine ways of creating pods. So when we get to the later sections of this course, we're going to see how you can template files and use Helm, for example, to reuse template files and create things much more dynamically. If you want to kind of hard code things and you're happy with that, this is great for learning. In the real world, you're going to use way more templating, especially with Helm or Customize or other sort of applications. This is a good way to kind of get started and learn how pods are actually run in Kubernetes, how to create them and check the resources and everything like that. So for this, we've got everything running. Now I'll show you, for example, how to delete those. So we can do kubectl delete pod. We've got to specify the resource that we want to delete, pod, and then we give it the name Nginx. And that's fine. We also want to delete Nginx 2. If we're quick enough, we can actually, no, we're not quick enough. If you're quick enough, you can actually see those pods being deleted by the kubectl, by the Kubernetes API. And that's pretty much all there is on pods in a very basic sort of term. We're going to get into more details in the later stages of pods and how to check the logs and troubleshoot stuff as well, which is very important in sort of real world scenarios where you got to find out if something's not being started up correctly, where to check the logs, where they're being stored as well. But in terms of creating and deleting pods, this is a very simple start, and it will get you on your way where you can define a simple YAML file for your pod, define the image that you want to run in it, and you can check your application in there. So this is it for this lecture, and I'll see you again in the next one. So in this section, we're going to start looking at troubleshooting Kubernetes and the usual kind of stuff you would do in a real world scenario with Kubernetes. So I'm going to just create a deployment and expose it similar to what we did inside of our Minikube section earlier. So we're just gonna I already have it existing, so but that's where we can look at services. Yes, I do still have it, and it's still pointing to the right pod. So let's go over a little refresher. The main sort of things you'd kind of use is kubectl. The main kubectl commands that you would use kind of troubleshoot things is kubectl get, describe, get events, and logs, for example. I think those are the kind of main four that you would kind of do in sort of troubleshooting scenarios. So kubectl get po hello Minikube, for example. Kubectl get po. Oh, okay, it's got a different name because it's a part of the deployment. So let's po hello Minikube. You can kind of get specific pods. You can do sort of labels to kind of find things better. And now to describe this pod, we can also do kubectl describe, define the pod, and paste that again. And this gives us a lot more stuff. You can see the events here at the bottom that have ran through the container, for example, and for the pod, creating the container, create a container echo server, all different types of stuff, conditions, volumes that are attached, if they're attached, annotation, status, namespace that's in priority, service account pointing to default. So if you have like a crash backoff loop or anything along those lines, you can often find the reason in the events why it's crashing off. For example, an image can't load, like it can't pull the image from the server or something along those lines. You can see that in the events here. So another way to kind of see that, you can do kubectl get events, get events pods. And I can't remember. kubectl get events. Get events. kubectl just events, sorry. Events. We can see all the events going on in our cluster, for example, or in our namespace. The way to look it up for a pod, we'd have to define --4 pod and then the name of the pod. And you can see the same events that we had earlier in the pod down here. So once again, if you're trying to find anything for the pod, you can do this to get the events. These kind of show you everything going on in the cluster, essentially all of these. Everything in the default namespace that's going on in here, that's going on. So if you want to do kubectl get events or events for a specific namespace, you can do namespace red if we had it. No events found in red namespace because we don't actually have anything, but if we were to create a namespace, create ns red and go back to this, still nothing. But if we then create kubectl run pods nginx --image equals nginx -ns equals red. Let's do -- namespace equals red. Now we go to pod and we go back to our event from the red namespace. We can actually see our image being created in that namespace. Successfully pulled the image, started container pod, create container pod, and everything going on in there. So that's a good way to kind of find out if there's any events going on inside a namespace, inside of a pod that you are not aware of. You can actually filter them. So if there's anything that's a type of a warning or error, I believe, or you can see here normal, we can actually filter that as well. If we do -types, I believe, and then equals, for example, normal, it's kind of same. We can actually look for warnings as well. Oh, there we go. Back off, failed container pod, then pod red. So if we do kubectl po-n red, kubectl get po-n red. It's actually in the crash backoff. There we go. It's currently restarting. I wonder why. kubectl, let's do logs. Logs -ns red. And then what do we call nginx? Let me just double check the logs command. kubectl logs -n red -- all containers, and then red, I believe, ctl. Pods red not found in namespace red. Oh yeah, because it's called nginx. Red. Oh, I just called the pod. Okay, never mind. I think I created that pod off wrong. So let's see. These are our logs from all the containers inside of the pod, for example, here. This is a great example of how I usually troubleshoot things. Just run through all these commands and have a look for what went wrong in this pod. And then as you can see here, let's see again, checksum enable list. I think we just defined our run command wrong, so we can go back. kubectl delete pod -nred, and I call the pod kubectl run nginx -image equals nginx. I think I just specified it wrong because I think I typed in run pod -namespace equals red. kubectl get po -nred, and there we go. Now it's running. So we can go back to events -nred container created. So that's, see, we managed to get an error going for a pod. We just specified it wrong. We created a pod named pod with an nginx sort of variable that wasn't there, and it was actually in the crash backup loop. And we were able to troubleshoot and use it using these kubectl commands, using the logs command, the events, and figure out that something was wrong. And we could have figured out that, oh, we probably specified it wrong, able to delete it and create it again, and now we've got running pod correctly in our new namespace called red. Get PO. And everything's fine now. So this is a quick sort of lesson on how to troubleshoot things in Kubernetes. The kind of main commands you want to go over again are logs and events. Logs will kind of give you a more in-depth look of what's going on inside of the containers inside of the pod, so you can, like, if you have a sidecar container or your main container running in the pod and one of them's failing, you can check what's going on there. Events give you a whole sort of overview of usually the namespace, but you can, you know, tone it down just to a pod or other resources in the Kubernetes API sort of resources way. So this is it for this sort of quick troubleshooting lesson on how to troubleshoot issues with pods. We're going to get into more in-depth stuff with each of these commands in the next few sections, just a deeper dive into them and all their possibilities. So stay tuned for that. In this section, we're going to talk about deployments. Deployments allow us to manage a set of pods to run the application workload. So usually you just don't want to create just one pod. You kind of want to have a few pods running of the same application. So deployments is the way to do that. So I'll show you just a quick way how to create deployments. Let's create a new file, deployment.yaml. And here we can see it's a similar sort of structure to what we had before, where we define our API version. This one, as you can see, is actually changing from v1 to apps/v1. Slightly different version of the API. The kind is still deployment, and then we have our kind of usual sort of stuff. What changes here is we define the number of replicas selector that it matches to in terms of the labels for if we ever do our service that we want to expose to or match it. Specs here of what's actually going to be running. Now we just change that image instead of 114, or we can keep it as 114. So now if we do, for example, kubectl apply deployment, we can see kubectl get deployments. We can see our nginx is up and running. We've got 3 out of 3 running, and we can just make sure that these deployments are running. The one thing you might notice, for example, now, when we were creating our pods and we just called it nginx, it didn't have this sort of unique ID here. This is kind of just like a way of separating those names, so it's not always like a UID that's not the same. So it's not always like nginx deployment 1, 2, 3, because you might run into problems sometimes if a pod's going up or down or something like that. So this is just a simple way of kind of creating deployments that has more than one pod. The kind of main commands that you can kind of run with this is actually scaling these up and down, which I'll show you right now. So now we use kubectl scale command. So we do kubectl scale We can change the replicas to, let's say, 5 now. Replicas, let's type in replicas, yes. Deployment, which we called our deployment. What did we call it again? nginx-deployment. And there we go. This is how you can simply scale the deployment up and down. So now if we do kubectl get deployment, you'll see that we have 5 ready and 5 up to date, and we can just verify that by running checking our pods. Now we have 5 nginx pods running. You can see by the age, the initial 3 are about 2 minutes old, and the new ones are just a few seconds old. So this is how you can scale it up. You can do the same thing for scaling it down. So if we just go back a few steps, we can scale this down as well. And then we can just check again, get deployment, 2 is running. If we're quick enough, no, we're not quick enough because they're quite small images, so it doesn't take long to bring them down. But you can see our pods have gone down to our sort of desired amount. So this, in a nutshell, is how to create a deployment that you can scale up and down and create a bigger workload or a smaller workload depending on your needs. So thanks for watching this section. A big part of Kubernetes are services. So services allow you to expose your application running your cluster behind like a single outward facing endpoint. So say you have a deployment, or just let's say you got deployment. You got deployment of 3 pods running to kind of create this sort of network connectivity to split the service to go to each one depending on availability or load balancing. You want to use a service. So in this section, we're going to go over just the basics of services and how to create them. The sort of key aim of services is that you don't need to modify your existing application or use like sort of mechanisms like nginx or stuff like that, kind of like forward-facing ingress sort of stuff to make everything running. So there's a few ways to kind of create deployments. In the next part, I'll show you like just a quick sort of creating like a deployment and a service. In this section, I'm going to show you just how to create a pod and a service. So the easiest way to kind of visualize this, let's create a new YAML file called vim services, and type at this point. And I'll just pull up the sort of example that they give you on the Kubernetes documentation. And let's go through this. So this is the kind of usual sort of structure, YAML structure file that we're kind of used to, where we've got our API version. We kind of split over here. We've got, first of all, we're defining our pod, which is going to be, again, an nginx with a label of proxy and the container running inside of it. The service, as you can see here, the biggest part, how the service selects what pods to pick up, is this selector part. Selector, we can see it's going by this label that we've created, app kubernetes io.name and proxy. So once that's done, so you can define many pods if they have similar labels. You can change that label to something else. You can have a like group or something, and that service will join them up together. So let's save this file, and then we can just apply kubectl. Actually, let's just do just let me make sure I don't have any more pods. Kubectl pods get po. Kubectl get po. We do have one, so we still have our deployment running, so let's delete our deployment from earlier. Delete deployment hello Minikube. There we go. So now we can just double check we don't have anything running. Why am I just typing get po? Get po. There we go. So let's apply this kubectl apply -f services. So now we can see it's created our pod and our service. So let's see, kubectl get service. We can see our new service there, nginx service. By default, it creates it with a cluster IP, so it's not sort of like outward facing straight away. We can expose this using a node port, which is not recommended apart from testing. Node ports are kind of good way of testing if your service is working, and you can kind of point it to a port, and then you can actually see it inside of your browser. So you've got like a web application, you want to expose it, make sure everything's correct. By default, it goes to cluster IP. Another type of services that you get is a load balancer, where it splits but basically load balances your application and pushes it to wherever has the most resources to kind of handle the load. The kind of good thing with load balancers, when you're using a cloud provider like AWS, you can define labels that will actually create a load balancer type for you. Like I think it usually creates an application load balancer unless you define it to be a network load balancer. It'll create that for you and use that load balancer as your kind of like type for the service, and that will then distribute the application correctly. So this is pretty much it in terms of like how to run it. But if we want to then expose it, there's a simple command we can run, which I'll show you just now. So we can just do it with this command, kubectl expose service. And we'll do the call service nginx service, and then we do -- port, which is our container port, which is 80, and then the target port, let's go 8443, and then name goes nginx service expose. And there we go, we have exposed our service. And now if we do kubectl get service again, in this episode we're going to create our first deployment and look how to expose services in Kubernetes. So you can still get this from the documentation on the Minikube site. All you have to do, for example, is type this in kubectl create deployment hello Minikube, and you provide an image as well that is default, like that is created by Minikube, which is just act as a server. Now to find this, we can do kubectl get po, and we can see it's by default running in our default namespace, funnily enough, because we haven't specified any namespaces. And you can see hello Minikube, the deployment's ready, one pod is ready and running. So now to expose this deployment, we use this command, kubectl expose deployment. We are doing it with a type no port, and we want to expose the port 8080 from the service. Now we can actually see kubectl get services, and we can see that our service right here is being exposed with a type of node port. We can set the cluster IP, at the moment doesn't have an external IP, but we can see a port 8080 is being exposed. The easiest way to access this with Minikube, you can actually type in Minikube service hello Minikube. If I can type Minikube, and it will actually tunnel your service to a local port. If you hit Command or Control and Enter, it will show up. So now we can head over to our browser. It will pop up, and you can actually see the server there and what's running on it. So this port forwards the service, exposes it, and you can actually use it in a browser. So that was in very quick terms on how to create a deployment and a service and how to expose it, so you can actually see. So for example, if you have an application that you want to run in Kubernetes, you can create a service, expose it, and start seeing it in the browser, see if your application is looking the way you want it to look. In this section, we're going to look at service accounts and how to create them and assign roles to them. The main sort of use cases for service accounts is giving permissions to your applications and pods instead of a namespace. That's how I usually do it for certain specific actions inside of the namespace or inside of the cloud. The main sort of example I can give you guys is, say your code is doing something with AWS and, for example, S3. Let's say it's uploading images to an S3 bucket. It's pulling them in. Usually you can define in your code that it's pulling in some API keys, and that's how it's doing it. With service accounts, you can define, I think it's annotations or labels, specifying the service account name and the role you want to bind it to from AWS. And that will actually give it enough permissions to interact with the AWS API and actually assume that role. So that's one of the main benefits when you're kind of like in one of those ecosystems in terms of like Google Cloud, Azure. I'm not sure if Azure works as well, but it still works pretty well. But AWS is specifically where you can create IAM roles and actually bind them to the service accounts inside of Kubernetes, which is really cool. And it streamlines so many sort of permissions and the ways of working. So in this sort of example, we're just going to create a basic service account and add a role of just getting secrets inside of the namespace. So let's just create a new service account, create service account. I think it was create service account, and let's call it like secrets getter. So we have created our service account called secrets getter, and for this let's create also a role now. So now we'll do create role. We need to pass in a verb in here, which is the kind of verbs you would usually use is get, list, or create or delete, so kind of limiting the sort of actions you can do inside of the namespace. So let's do get and then verb, and then I completely forgot role. What's the resource? -- resource, yeah, resource, and let's call it secrets create role, and we also need to specify the name here. So let's call it secrets getter. Yeah, so and now we have our role, which is namespaced. Another big part that I forgot to mention, there's cluster roles and normal roles. Roles are namespaced, cluster roles are cluster wide. So in kind of like best practice and limiting access, you kind of want to limit as much as possible to just sticking with roles. Cluster roles are kind of for more of your agents that are trying to get logs or admin sort of permissions and actually run stuff. So you really want to stick to roles as much as possible and not give it cluster-wide permissions. So now let's just create a binding here. So let's do kubectl create role binding. Create role binding. Let's call it secrets getter. It's kind of the best practice, or kind of follow the naming convention that you kind of stick the role binding and the role as close together as possible. And then we do -- role and call it secrets getter. And then we do our -- service account. I think it's -- service account, I believe. Let me just double check so I'm not lying to you. -- service account, yes. And service accounts are usually, whenever you're referencing them inside of like sort of arguments, it's always namespace colon and then the name of the service account. So our service account was in the default namespace, and what do I call it? Secrets - getter. And there we go. We've got our role binding here. And we can check out kubectl get role bindings, and we got secrets getter. I've got a few other ones that I've created earlier, but this is the main one, secrets getter, that we have it, and we can actually describe a kubectl describe role binding secrets getter, and we can actually see service account that it's using at the moment and binding this role to secrets getter default, and the role kind that it's actually the kind of role, which role it's assigned, it's binding it to the secrets getter here. So in a nutshell, this is the kind of quickest way in kubectl and Kubernetes how to create roles and assign them specific permissions to kind of limit sort of access to certain pods and stuff like that. So this is it for this section. We're gonna, in our AWS section, I'm gonna kind of go over more stuff on how to actually get roles that are getting IAM roles attached to them and how to do that. So thanks for watching, and just stay tuned for the next lesson. Another big part of Kubernetes is secrets. There's a lot of things that you want to keep secret and not be stored as sort of plain text. Kubernetes offers a resource named secrets, where it stores all of these in kind of base64 encoding, so it's not stored as plain text. In this section, we're going to go over just how to create generic secrets. There's a lot of type of secrets. There's generic secrets, Docker registry secrets, and TLS secrets. And obviously those have different use cases. Docker registry to kind of pull images from different registries. TLS secrets are quite often used for communication to enable pods to communicate over TLS, or you have certain keys to create sort of other routings. We're just going to create a sort of basic secret list from just a literal. There's a few options which I'm going to link to in the documentation in the code section here. So let's just create a generic secret. So we do kubectl create secret generic. Let's call it generic. Not call it generic, but specify what type it is. Let's call it my secret, and then we define how we're creating this. So we can do it from literal, which kind of follows this key, and then value equals. So key pair sort of values. So key 1 equals super secret. And then we can also define another part from literal equals key 2 uber mega secret. And then that's it. You have your secret created, and you can actually describe it and view it. kubectl get secret, for example, secret my secret. There we go, and you can see that it's just created just a default opaque. I don't know how to pronounce this word. Someone might correct me in the comment section on how to pronounce this word. Opaque. I'm not sure. Secret. And if you're using this sort of viewer in terms of like lens or K9s, you can view those secrets quite nicely for the UI. I'll show you quickly a command on how you can decode these base64 encoded secrets as well. So for this part, we just use a simple kubectl command where we do kubectl get secret, and then we do, I think I called it my secrets, and then we just gotta specify that dash option to JSON path to get the data of the secret. Let me just do this correctly so I don't mess it up. And that gives us a base64 encoded secret, so you don't actually see what is there, but you can see the values there. So you can actually pipe it into base64 function here and decode. Piping in. Yes, because we are not. We don't have the value, but we can do this. For example, we can actually echo this part, and then we do base64 -- decode, and we can actually see this called uber mega secret here. You can also edit secrets quite easily if you actually use the kubectl edit command. It's kubectl edit secret my secret. We can actually see all the sort of keys here. They are still base64 encoded, but if you want to change them, you can also do sort of similar commands to update them and view them and stuff like that. So that's just a quick overview of secrets and how to create them, decode them as well, and get different stuff. I think the quickest way to do this, I can't remember if this works in JSON, but let's do key 1, I believe. Oh, it does. Okay. So if I do data.key1, so it's just the basic JSON path. I can never remember my JSON pathings. So .data and then .key1 and base64 decoded. You can actually view them here. There we go. You can see key 1's super secret, key 2's uber mega secret. So yeah, going back to this was just a quick overview of how to quite quickly create a basic generic secret and how to use them. If you're more interested in this or TLS and Docker registration secrets, they're very similar to this, but they have like a specific resource type that they work in a slightly different way than these. Most of the secrets that you'll be creating will be like just a generic secret for any sort of passwords, or for passwords to connect into the database that you don't want to store, and just sort of plain text, and then you can use them inside your pods and load them into envs and stuff like that, and etc. So that's kind of how you would usually use secrets. So I hope you guys enjoyed this tutorial and this sort of small course that I've created on Kubernetes and the very basics of it. I know I didn't go too too in depth into more sort of details on Kubernetes and the whole ecosystem and how you use stuff. But there's going to be a lot of videos coming up really soon, so please make sure to hit that like button and subscribe, and all the other stuff like the little bell icon if that helps as well. So I hope you guys enjoyed it. Please stick around for more, and make sure you watch our videos in the future. Thank you, and see you soon.